Right. So the domain and range that's important. So this whole thing is a function, and so let's play around with this a little bit. Pick out a number that I'm going to plug in for my input. 8. So we're going to say x equals 8. That goes into my machine. I say 8 plus 2. What's 8 plus 2? 10. So then I would write this in function notation. F of 8 is equal to 10. And where that comes from, let me back up. Erase that. We're going to put one step before that. F of 8 is equal to 8 plus 2. Therefore, f of 8 is equal to 10. Okay, so this should be a review, right? This is an Algebra 1 concept. But it's a lot of stuff to kind of soak in. So when I look at that as a mathematician, I go, okay, if I look at this, and this is what I'm trying to teach you today, if I look at this, I know that there is a function, it's a very specific type of equation, that when I plug in, now here's the tricky part, the x value technically is also the input. So technically, this whole f of 8 is the output. So if you look at it this way, this is the output value, right? This is the output value based on the input value. If I plug in 8, I'm going to get out 10. Does that make sense? So you're like, okay, cool, Mr. Adams. How many times are you going to explain this? So this is important. When I look at this as a mathematician, I go, okay, there's a very specific equation that when I plug in 8 for x, I get 10 for y, or f of x, right? But is there a scenario where I might reverse that process? The answer is in the real world, yes. We would need an equation that reverses what's been done, all right? So what we're going to talk about today are called inverse functions. So what we're going to do, there's a process for the inverse function, okay? And I'm going to copy it. And you're going to need to write this down too, but so the inverse function, just like any other inverse, undoes what's being done from a mathematical perspective. Okay? And that process, this is what you're going to learn today, hopefully, is that we can take an equation, specifically a function, do some algebra, and come up with another function that undoes what's done by the original function. Okay? So this is the process. There's a lot of steps. You won't memorize it or get it the first time, but probably about the third or fourth example, it'll soak in. You'll be like, oh, okay, I get it. So this is a lot to digest on the first pass. So anyway, so what I'm going to do is I'm going to take the equation and write it out. So in this particular scenario, I'll do it off to the side here. I'm going to say f of x is equal to x plus 2. All right. So the first step in this process, we want to find the inverse function of f of x. The first step is substitute y for f of x. So I just rewrite the equation y equals x plus 2. So that's step 1. Okay? Bless you. So step 2, solve for x in terms of y. I'm going to put in a 1.5 here, and we're going to swap x and y. Actually, you know what? They do it in the reverse order. So just forget that. The textbook, I usually do it one way, but the textbook does it another way. I'm going to do it the way the textbook does, so that way if you're at home and you look at your textbook, you're not confused. Well, Mr. Adams does it the opposite way. So we're going to solve for x. So in other words, I want to get x by itself and all the other stuff on the other side. So I need to move the positive 2 or the plus 2. How do I move the plus 2? Yep. So I'm going to do the inverse operation by subtracting 2 from both sides. Remember, whatever I do on one side of the equation, I have to do to the other. What's 2 minus 2? 0. What's 0 plus x? X. Y minus 2. Since I don't know the value of y, I just leave it like this. You guys with me so far? Okay. So that's step 2. And this is the process you're going to do for this whole section. Step 3 is switch the x and y. So that means wherever there's a y, I'm going to put an x. And wherever there's an x, I'm going to put a y. So do write this down, though. I like to write it this way. It seems to make more sense for kids if I write it that way. So there was a y here, right? Well, I switched it with an x. There was an x here. I switched it with a y. Okay? Lastly, wherever there's a y, this is called f inverse. So you're going to write f to the negative 1 is what it kind of looks like, but it's called f inverse is equal to x minus 2. So over here, let's write this out. F of x is equal to x plus 2. And then the inverse, f inverse of x is equal to x minus 2. And that makes sense, right? If I plug something in and the only thing I do is add 2 to it, the inverse would be what? Subtract 2 from it. Does that make sense? Now, this will get a lot more complicated as we go through and add more operations. But I picked the simple one on purpose. Okay. So let's unpack what that does. So what I'd like for you guys to do, grab a calculator. They should be on your desk. Okay. If you don't have one, there's one right behind you or something. And so let's write this. You guys don't need to write it out a second time, but Mr. Adams had to go to a new slide, so we'll just do it this way. So if I do, let's pick a value for, not that you need a calculator for this, but there's a part that I want to show you. If I plug in f of 1, right, that means I'm going to plug in a 1 here, and that means I'm going to get 3. In other words, f of 1 is equal to 3. Now, in this particular case, remind Mr. Adams, what is the input? Well, in this particular case, the input is 1, right? That's the input. And then the output is 3. Now, watch what happens when I say f inverse of my output, which is 3. I get 3 minus 2, which is equal to 1. If I write this in terms of a function as a machine, and then I process it through the inverse, I get 1 is my input. Let's put some numbers in here. 1 is my input. 3 is my output. But now my output becomes my input, and I get 1 as the output. So what I'm doing is I have a function that's like a machine that takes 1, puts it in, and I get 3. Now I've created another machine that basically just undoes that and gives me back the original. Does that make sense? Okay. Now this is the whole reason why we identify these equations as functions, because you can only do this with functions. You can only create an inverse function of a function. So let's try one more value. What do you want to do? Pick a number. 4. So f of 4 is equal to 4 plus 2, which is equal to 8. In other words, f of 4 is equal to 8. This is the input, and this is the output for f. Then if I say f of 8, what do you suspect that will equal? Before we do the math, what do you think that will equal? Yeah, it is 6. My bad. I did that on purpose to see if you guys are paying attention. You know what I did? I did what you guys do. I said 4 times 2 is 8. Yeah. Yeah, it's okay. Good catch. So now, then I need to change this then, don't I? So if I say f of 6, right? What do you think the output for f inverse of 6 would be? Yeah, 4 minus 2. Not 4 minus 2, 6 minus 2, silly goose. Which equals 4. Okay. So f inverse of 6 is equal to 4. Okay. In other words, if I plug in 4, I'll crank through the math and I'll get 6 if I'm doing my math correctly. And then if I put that through the inverse function, my output will be 4. Okay. Let's try another one. But I purposefully made easy equations because if let's do some in our head. If I plug in 3, what's 3 plus 2? 5. What's 5 minus 2? 3. Okay? Does that make sense? Okay. So the inverse undoes what's being done. So let's look at this on our graphing calculator. So fire up your graphing calculators. And let's clear out y equals. Yes. You did 4? Oh, okay. Hurry up and write that down. So while you're writing that down, go ahead and graph f of x, which is x plus 2, and y equals, I'll write it on the board, and then we'll do it. Are you done? Yes. Okay. So then let's graph these. So I'm going to say x plus 2, and go down and hit x minus 2. So we're graphing the inverse and the function. Now, one other thing, let's make sure our stat plots are off. So hit second y equals. Option number 4 turns all those off. So if you hit 4, right, remember that? Am I going too fast? Do you guys remember how to do that? We're good? All right. Hit enter. That's done. Now what I want you to do, we're going to try something different. What's the word above the graph button? Table, right? So hit second graph. That brings us to the table. So if I were to evaluate all these input-output values, there's an interesting thing that takes place. But let's write some of them down. I'm going to copy the first half, and then we'll verify on the calculator just for time's sake. So let's write this down. So we'll do another slide. Do you guys have the same numbers I do? So just jot that down real quick. So in other words, when I take and I plug in 0, 0 plus 2 is 2. 1, and you could even think like this. 1 plus 2 equals 3. 2 plus 2 equals 4. 3 plus 2 equals 5. 4 plus 2 equals 6. This is my input value being mapped to F. Okay, that's my input value being mapped to F. Now, the only thing that we're going to do different is over here, we're going to do the Y2 values. And what do we do mathematically to get the Y2 values? Well, actually, you know what? Let's do it differently. Yeah, don't write that down. Two to 10. So this is my X value here. And this is my F inverse. So what I'd like to point out, I'll stop talking first. Well, I'm going to keep talking, but I'm going to give you time to write all this down. Now, this is verified from the calculator, right? What do you notice? I notice that when I plug in an input value into F, okay, when I plug in an input value for F, whatever that output value is, if I plug that output value in for the input value to F of or F inverse, I get my original input. Okay? So as you're writing this down, notice that when I plug in X to F, I get 2. When I plug in 2 to F inverse, I get 0. Wait, did I say that wrong? When I plug in 0 for X to F, I get 2. When I plug in 2 into F inverse, I get 0. So there's a pattern. If I plug in 1, I get 3. If I plug in 3, I get 1. If I plug in 2, I get 4. If I plug in 4, I get 2. So F inverse is literally reversing mathematically what I've done with F. So I'm going to pause for a second. When I say F inverse reverses what F does, how do you guys feel about that concept? Thumbs up if you get it. Thumbs down if you don't. It's okay to be here. This is one of those topics where I'll do this. I'll explain the exact same thing with a little bit different formula, and you'll be like, "Oh, okay." It's just like before. Okay. All right. We have one last thing to do. I'm just waiting until everybody stops writing. What I'd like for you to do on your calculator now, let's go and click on Zoom. Zoom. Do you have your calculator? Click on Zoom, and then we're going to do standard fit. So hit 6. Oh, Mr. Adams turned his graph off. My bad. That's why it looks a little funny. All right. So now the other one last little thing I got to tell you about inverse functions is they reflect across the diagonal. Yeah, let me talk for a second and then I'll tell you what to sketch. Okay. So they reflect across the diagonal. So go to y equals, go down to y sub 3 and just put an x there. And let's change the color to green. Right? You guys remember how to change the color? I'll go a little slower just in case. Let me. Yeah, you just move the cursor over to where this little box is, and it'll pull up this menu. Then you go through the colors like this. There we go. Then move the cursor down, and then hit equals. Actually, I might change the line too. Let's change the line. Do I have the dot? Where's the dot? There it is. I'm going to change my line to dotted. You'll see why in a second. All right, hit enter. Oh, it doesn't make a difference. That's all right. Let me take a screenshot. And yes, I do want you to sketch it. So this is what I want you to sketch. Just this little thingy here in your notes. And so my red line is f of x is equal to x plus 2. My blue line is f inverse of x, which is equal to x minus 2. And then my green line is, we'll say y equals x. So whenever you have two functions and you find the f of x and the f inverse, they will always mirror across the diagonal, which is y equals x or f of x. If you notice, the red line mirrors the blue line symmetrically across that green line. Okay, that's always the case. So one way, if you're doing a standardized test like the SAT or something, and they say which one is the inverse function, I'm going to teach you a long, complicated algebraic way to find the inverse function, but you could actually graph it in about 10 seconds. Right? SAT is a time test. So you just put in the inverse function and the function, and if they're symmetrical about this diagonal line, then you know that's the inverse. Okay? Okay. Any questions